Okay. So as a review, okay, we have these rules for assigning oxidation numbers, and just, okay, a review, because I know I taught this topic already. Remember that all elements, when they are in their free state, which means that they are not combined with other elements, they have an oxidation number of 0. Okay, so pure elements like just copper or magnesium or diatomic elements, remember what the mnemonics that I give you to memorize the diatomic elements. Have no fear of ice cold beer. Okay, so the diatomic elements plus pure elements, when they are not combined, they are going to have a free state or of oxidation number, sorry, that is equal to 0. Okay, now we have the duality of hydrogen as the second rule of oxidation number. That is, hydrogen is going to be +1. Okay, most of the time, except when it's combined with a metal. So in that case, hydrogen becomes hydride. In that case, the hydride is going to have a charge of -1. So first rule, elements uncombined have 0 oxidation number. Hydrogen is going to be +1 most of the time, except when it is combined with a metal. That's why you have to know the elements of the periodic table. At least you should be able to recognize those elements in the periodic table. I don't know why these people are coming late to my class. Oxygen, the rule of oxygen. 99% of the time, oxygen will be -2, except when it is in peroxides, where the charge of oxygen over there is going to be -1. And in oxygen difluoride, when it is +2. This exception occurs because oxygen and, okay, fluorine is the most electronegative element, okay? So it is related to the rule number 5, which says in covalent or molecular compounds, the negative oxidation number is assigned to the most electronegative atom. So in this binary covalent compound that I have over there between oxygen and fluorine, it is molecular because the two are non-metals. And the most electronegative atom is going to be fluorine. Fluorine is the most electronegative element throughout all the periodic table. So in that case, fluorine will be using the charge of -1. And in this case, oxygen is going to be +2. But that's the only exception of the rule. And so I told you, 99% of the time it's going to be oxygen -2, except when you have oxygen difluoride or when you have a peroxide. Then we have the rule number 4, that is that metallic elements in ionic compounds, they will always have positive oxidation number. Then the rule 5, I was telling you, okay, the most electronegative atom is going to have the negative oxidation number. Then rule 6 and 7 is exactly what we're going to be working on today. Is the algebraic sum of the oxidation numbers of elements in a compound is 0. So in compounds, when we add all the oxidation numbers, it's going to give you 0. It's balanced. But when we have to calculate the oxidation number of ions, then it's going to, that sum of the oxidation number is going to be equal to the charge of the ion. Okay, so I'm going to teach you an oxidation number, but in a way that we can work faster, because in redox it's a long process and taking so much time in calculating the oxidation numbers is a waste. So I'm going to teach you a method so you can do this quicker. Okay, so let's see. I'm a nice person, so I'm going to start with a good example. Okay. So first thing you have to see is if this is a compound or an ion. What is this? A compound or ion?
Compound.
Compound. You see no charges, so it's compound, okay? That means that the total charge, the net charge of the entire compound will be equalized to 0 because you will apply the rule 6. That means that you will equalize to 0. That's the rule 6. And the rule 7 is that you will equalize to the charge of the ion in the case of ions. Okay, in the case of ions or polyatomic ions, it's going to be equalized to the charge of the ion. So I know the charge of sodium because it's there in the periodic table. It's part of the group 1A alkali metals, so you know that the charge is +1. You know the rule of oxygen, that is -2, which means that we need to find what nitrogen is. So I will transform this compound into an algebraic expression, okay? So I will say that, okay, remember that we have invisible ones over there in sodium and nitrogen. You don't see them, but they're stuck in you. So we have one sodium and we have one invisible one nitrogen. And we have 3 oxygens. It's like when you calculate the molar masses, more or less. But instead of using masses, we're going to be using the charges. And we'll be equalized this to 0. Now, I know sodium, I know oxygen, so I'm going to look for nitrogen. So 1 sodium is going to be 1 times the charge of sodium, that is how much?
1.
1. And 1 N is going to give me just N, just nitrogen. And 3 oxygen is going to be 3 oxygen is going to be 3 O's, 3 times the charge of oxygen, that is -2. It's not a peroxide, okay? It's not OF2, so it's going to be -2. So 1 times 1 is 1. 3 times -2 is going to give us -6. How much is this?
-5.
And to find this 5, okay, you're going to isolate. Is subtracting, we'll go to the other side to add, okay? So nitrogen will be equal to +5. That's the normal method that I teach, okay, for calculating oxidation numbers. But as I told you, this method takes time. So if we can do things faster, that is better, okay? Now I'm going to teach you this. And please pay attention because most of the work that you will do here is going to be mental and you cannot see my mind. Yes. Don't freak out, Chrissy, okay? It's nice. Okay. So I know the charge of oxygen. That's one of the rules that I will be applying like most of the time. So I say, I do this, okay? I know that this is -2. I know that this is 1. This one is my x, because I don't know it. Okay. So I say 3 times -2 gives me -6. Okay. Here I have a invisible 1 times 1 that gives me 1 positive. So what number I need to place here in order for this to be balanced? Because I need to have +6 in the positive sides and -6 in the negative side. The negative side is going to be my oxygen in this case. What number I need here for it to be balanced? To what number I need to add 1 in order to get 5. So here I have 5. Wait. So 1 and 5 make 6. And here you have -6. And 6 minus 6 gives you 0. With this, you know that the oxidation number that you just got is correct, okay? Because it was equalized to 0 in the end. Did you get the idea? It's easy, right? I told you. But it's kind of, because you cannot read my mind, so I tried like to project what is going on in my head. Okay. Okay, what is the name of this compound, by the way?
Copper tetraphosphorus. Sorry.
Phosphate.
Okay, no, I didn't want to laugh. Okay, as a review as well. Copper is a transition metal that has multiple charges, +1, +2, okay? So it has 2 possibilities. Because here I don't see any substrate, I know that the charge that is coming from copper is invisible 1. So this is copper 1. It's a transition metal with multiple charges. Copper 1, okay? And this is called phosphate. Phosphate, it's a polyatomic ion that has a charge of -3. So that's the name. What I just did in the beginning, just to find the oxidation state of copper, that's something that I do mentally. That's something that you should do also mentally because it's better. Now, take a look. You have a periodic table with you that is useful. Okay, so try to see whenever you have a polyatomic ionic compound, try to see always the metal. The metal is the one that has the positive charge always, okay? Now, if you look for copper, which is the element 29, you will see the charge +1 or +2. In this case, it's 1. Because if it was 2, you will see this in the parentheses. So it cannot be copper 2. So the first thing that you do is you get mentally the oxidation number of copper, okay? If you cannot do it mentally, you can do it in a separate sheet of paper or in a post-it, okay? But it's gonna take time. And you don't want to waste time in this. Okay, so you have copper plus 1. You have the charge of oxygen. This is not oxygen difluoride. It's not a peroxide. So the charge is -2. So 4 and -2 is going to give me how much?
-8.
-8. Okay. So from here, in the negative part, I got -8. In the positive part, I have 3 times +1 that is given me plus 3. So what number I need my phosphorus to be if I want this to be balanced?
5.
3 and 5 makes 8, and 8 minus 8 gives you 0. So, see, it's easy. It's easy. I told you it is easy. But it requires practice, okay? It requires that you guys know the oxidation states of several metals. So, during this weekend, do yourself a favor and try to review those elements that have multiple charges. Just for you to identify, for example, I know that silver, besides, despite of the fact that silver is part of the transition metals, I know that silver is one of the exceptions because it has only a charge of +1. So anytime I see silver, I know silver is +1. For example, I know that cobalt, nickel, iron, gold, those are pretty useful elements, lead, tin, those are elements that we use a lot, in exercises. So, and I know they are, they have multiple charges. So what do you have to do? Just do yourself a favor and just try to review those elements that are familiar to you, because I'm telling you, it's very unlikely that I'm going to be using iridium in an exercise, okay? So try to see those elements that we use like the most and try to see the charges just for you to identify when are they, if they have multiple charges or not. Another one that I use a lot is manganese and chromium. They have like multiple charges. So that's my point, okay? Now, when it comes about parentheses stuff, it's kind of, but at the same time is it's good, okay? It's good. Let me show you another example. Okay, my connection is slow again. Can you hear me well? Okay.
Yes, miss.
Okay. So, what is the charge of iron?
3.
So you know the charge of iron, you know the rule of oxygen, that oxygen is -2. Okay. So I need to know sulfur. Okay, that's what I need to know. I need to know sulfur. But the sulfur is in parentheses. Okay. Now, well, I'm going to teach you in the easy way. Okay. Also, it doesn't mean that you cannot work with parentheses, which is very likely to occur. But right now, the easy process, and then with the parentheses. Okay, so take a look to this compound over here. We have parentheses, okay? And we have a 2 iron, and we have 2 iron, and we have this 3 that is multiplying this entire ion. So you can split this compound by saying that you have 2 irons and that you have 3 sulfates. Okay, you can say that. Now, as you already said, Christy, the charge of iron is pretty obvious. It's right here. And you know that this atom is coming from the charge of iron. Okay, so from this, you can tell that the charge of iron is 3. Okay, now, what is the charge of the ion sulfate? Of the entire ion sulfate? Okay. I remember when it was the beginning of the school year and you remember those charges and now you don't. What a disappointment. Is that in your textbook? In the table of the polyatomic ions, okay, I'm going to say it better, okay? So you have 3 outside the parentheses and the entire charge of sulfate is -2. Is there in the table of the polyatomic ions? I will send it to you. No, not right now. I don't know where my phone is. Okay. Well, when the class is over, I will send you the table, but you have to trust me on this one, okay? The charge of sulfate is -2. So you can basically see that it's balanced, okay? You can see that it's balanced because 2 and 3 make 6, and 3 and -2 makes -6, and you add the 2 is 0, which it means that it's balanced. But that I don't want to see if it's balanced, okay? I want to know what is my charge of sulfur. So I'm gonna take my sulfate ion and I will say, okay, sulfate, it is an ion. Therefore, I will use the rule number 7. The rule number 7 that says that when it's an ion, you will equalize to the charge, okay? So SO4 is gonna be equal to -2. Okay, you know the rule of oxygen, okay? So you say sulfur plus 4 oxygen equals -2. Sulfur plus 4 minus 2 equals -2. Okay. Sulfur minus 8 equals -2. Sulfur equals -2 plus 8. 8 was subtracting, goes to the other side to add. So my sulfur is making a 6. Okay, that's how you do the process. And it's okay. It's okay. So how do you do this mentally? Because to do this takes time, okay? To do it mentally also takes time, but it is faster. So how do you do this mentally? I know that is hard to transmit an idea that most of the process happen in my head. Now, to have all this process in your head, you need to study, you need to review things that I already said, that I already explained. Okay. So we know the charge of iron, that is 3. We know the charge of oxygen, that is -2. And we don't know sulfur. Okay. So this mentally, I do it like this. 2 and 3 make 6. Okay. And here I say 2, 4, and 3. Okay. So I have 2 times 4 times 3. That is -24. Okay. So how much is sulfur? Sulfur, remember that sulfur is being affected also by these 3. So actually I have 3 sulfurs. So how do I do this? I do 24 minus 6 divide, which is 18, and then I divide by 6, sorry, by 3. How do I do this? This gives me 6. How do I do this? To the 24 I got from oxygen, I subtract the iron. To the negative part, I subtract the positive part. And then I divide by the coefficient next to my unknown. So 24 minus 6 gives me 18. Then I divide by the coefficient of sulfur, that is 3. In total, it gives me 6. Okay, so 3 times 6, that is 18. 18 and 6, that makes 24. And 24 minus 24, that makes the 0. You don't see the process because my connection is slow, but you will see that it will appear slowly, step by step. There you go. So whatever method you prefer, it's okay. But just know that if you choose this method, okay, the mathematical procedure is not wrong, it's good, but it takes time. And redox is a long process, okay? So just consider that. Just consider that.
Miss, show the last one that you made, the one that it doesn't look.
This one.
Yes.
Okay. So remember what I do here. My oxygen minus iron. The total I get, I will divide by the subscript that is next to my unknown.
And why did you get 0, Miss? And you know, I know that you multiply 3 times 6 is gonna be 18, and 18 times 6 is gonna be 24, but the 0 that is there, where do you get it? Because of 24?
Because of that 24 minus that 24 from here.
And the 6 that you get in the process when you divide, why did we did that process?
What process?
In the one that you get 6,
this
24
one.
minus 6, yeah.
This is like the procedure that I do in my mind that I told you. From where do I get these numbers? I mean, this 6, I mean, is that, you know that now you know that sulfur is 6, but now imagine that you don't know that sulfur is 6. You have to get it. From where do you get it? Okay, from where, this is one method, this is another method, okay? So in this moment, you don't know what sulfur is. To find it, what I do is I get all my oxygens first by multiplying charge of oxygen times the number of atoms of oxygen times the 3 that is outside the parentheses, giving me a total of -24. Okay, the iron gives me 3 and 2, 6. So to get this sulfur, what I do, the procedure that I do is to the oxygen I get, I subtract, I change the signs, okay? And I subtract the 6, okay? To the negative part, I subtract the positive part, and then I get